Hi everyone, welcome to our cognition unit. This is module 31, and in these next three modules we're going to be talking about memory. And memory is a very important topic to the AP exam, so you want to take careful notes and pay close attention. Here are your learning objectives, and here is your vocab. So let's start with what is memory. So simply explained, memory is learning that has persisted over time. That's it. Memory models. So the first thing that we need to know in how our memory works is the three-stage process of making a memory. The first is encoding. This is how the information gets into our brain. The second is storage, and this is about retaining the information over time. You're storing it. And finally, retrieval is the process of getting that information out when we need it. So I like to think of this as a Word document, not a Google Doc, a Word document. You type in the information, you're paying attention to it, typing it in, that is encoding. You hit the save button on your Word document, you are storing that information. And when you later go to look for that document, you are retrieving it from your files. Our brain doesn't really work like a computer and save files so nice and neatly, but it really helps kind of visualize the stages of memory. So encoding, storage, and retrieval. Parallel processing comes up as a vocab word in this unit again because in relation to memory, we are processing all sorts of sensory information at once, and we are recording some of that information, right? So in our memory, we have what's known as short-term or working memory. This is not what a lot of people think. So a lot of people think, I have such bad short-term memory, I don't remember what I did half an hour ago or what I did yesterday. Well, short-term memory doesn't really mean that. Short-term memory is what we are thinking about in that moment. So for example, when you are calling someone and maybe you're rehearsing a phone number in your brain, right? They told you verbally, you couldn't write it down, and now you're just trying to type it in while you still have it. Well, where you have it is your short-term memory. Now, because that name is so confusing, there's an updated name that we prefer, and that's working memory. Now, both of these are vocab because sometimes they'll use short-term memory, sometimes they'll use working. It means the same thing, it's just that the term working memory makes more sense. It is what we are working on right now. If you've ever heard the term executive functioning, and then you look at this graph, this chart over here, so our executive functioning is our working memory. It's our ability to take information that we've heard, information that we've seen, and maybe stored information from our long-term memory and put it all together and be thinking about it consciously in that moment. In order to have memories, well, first we have to sense information. We have to hear it, see it, experience it in whatever sense we are experiencing it in. So sensory memory is immediate, it's very brief, and it most of the time just goes away, right? Iconic memory is, think of icon or eye, it's visual memory, and this lasts about 1 second. So for icon, think of an eye, you can think of an icon on your computer screen, it's visual. Echoic, think of an echo. It's auditory memory, which lasts for 4 seconds. Now, obviously, any sort of sensory information can last more than 1 second, last more than 4 seconds, if it is attended to. So if you look at this concept map down below, if you pay attention to something that you are seeing because it's visually appealing, maybe it's emotionally charged, right? Then obviously you're thinking about it and remembering it longer. It's in your short-term working memory. So our long-term memory is permanent and limitless. There is no max of memory we can have, unlike computers and iPhones and all the rest. And it can be permanent, it can be our whole. There are two types of processing. When we are taking information into our memory, there's two types of processing you need to know. The first is effortful, and that's encoding that requires our attention and conscious effort. So, for example, learning this information requires your attention and conscious effort. And then there is automatic processing, which is unconscious encoding of incidental info, such as space, time, frequency, and of any sort of well-learned info. So, for example, when you first started learning how to read, that was effortful processing. You were sounding out each letter and putting them together and effortfully trying to figure out what those words were. That's effortful processing. Eventually, your reading became automatic processing, meaning you didn't need to sound out each thing. You could just see that word and automatically know its meaning. So things that once were effortful can become automatic. And for example, reading sentences backward is probably not something that you do regularly. So if you were to read a sentence backwards, such as the sentence on this page, that might require effortful processing. But over time, if you were to practice that, it could become more automatic, just the way you read forwards. So along with this are two types of memory: explicit, which are facts and experiences we consciously know and declare, also known as declarative memory. Implicit memory is retention without our conscious awareness. So for example, like riding a bike or driving a car could be implicit memory. We derive how to do those things unconsciously. We don't need a conscious awareness of how to pedal. Whereas in explicit memory, you do need that conscious thought process to retrieve. I'll graph to explain these more. So let's go back to our short-term working memory. So there was an important study you need to know conducted by George Miller, and he found that our short-term memory can retain about 7 pieces of information, plus or minus 2. So our magic number for memory is 7 plus or minus 2. In his study, he asked people to remember 3 consonant letter groups. So like CHJ. So he found that after 3 seconds, people recalled the letters only half the time. After 12 seconds, almost no letters were recalled. So if you look at this graph, you can see that immediate recall is good, but that drop-off is really fast and really strong. So that's in seconds on the bottom, right? And that is with no rehearsal. So they're not repeating it over and over. It's only that one time. CHJ, done. That's it. Compared with young children and older adults, young adults have more working memory space. So it helps them, basically, the word multitask isn't the best word, as we've already discussed. If you think of working memory as kind of like a workspace on your desk, well, young adults have a bigger workspace. Their central executive functioning has more space to do what it needs to do. Effortful processing strategies to help recall. So these are things you can use, and maybe you do. Chunking. It's taking bits of information and putting them into more manageable units. So if our magic number is 7 plus or minus 2, let's make it work for us. So instead of remembering these random words, you can basically group them into things that you know. So instead of just cat, ABC, IBM, XYZ, etc., you can do cat and hen. Those are animals. Okay, I'm going to think of those together. IBM and KFC, those are both companies. I'm going to group those together or chunk those together, and etc. You get the idea. So chunking things together is a way to kind of like trick the system. Okay, if my working memory space is about 7 bits of information, how can I maximize each space of those 7? Mnemonics, I'm sure you're familiar with these. So there's our memory aids, and they're especially useful if they are vivid imagery involved. So we're really good at vivid imagery. I always say, like, make it really weird, maybe kind of disgusting, or really like visually like, oh my God, imagine that. If you can do that with any of your information, you're much more likely to remember it. So one kind of mnemonic that does this is called peg word, and peg word uses visuals to connect information to like a standardized peg system. So over on the right, we have 1 is a bun, 2 is a shoe, 3 is a tree. You might have heard these before. So you pair your information you need to know with those peg system words. So for example, if you're making a grocery list, can't write it down, you'd think, carrots. Okay, those have to go with our 1 is a bun. So you put carrots inside of a bun. You like picture that. And then for 2 is a shoe, okay, I need milk. So I'm going to take that shoe and I'm going to fill it up with milk. And you have to visualize these things, and that will help you remember them in order. We can try this in class. And using chunking and mnemonics together, like Roy G. Biv, that's even better. So another thing that is excellent for studying, that is so overlooked, and it takes thought, so people don't want to do it. But thought is where you save time, people. If you consciously think about the information, your studying is greatly reduced. Hierarchies is an awesome way to study. When we organize words and concepts into hierarchical groups for more efficient recall. So the more you kind of become the more you know a topic, the more you are able to create really thoughtful concept maps. And so doing that with your psych information, for example, is a great way to study. So take that information, how can I connect it all together? Distributed practice, we've talked about this a lot in class because this is research. It's spreading out one's studying over time. This is much more effective than what is called mass practice, which is basically cramming all the information maybe the night before, or just in one night in general. Spacing it out is better. So spacing effect is the tendency for distributed practice to yield better long-term retention. So the difference between distributed practice and spacing effect is just that spacing effect is the result of distributed practice, that we remember more because of distributed practice. And testing effect we've also talked about, and that's enhanced memory after retrieving rather than simply rereading, also known as retrieval practice. Testing, so it could be called testing effect, it could be called retrieval practice, or test enhanced learning, which you don't hear as much. So here is someone who studied using spaced learning, is the blue line. Normal learning is that peachy color. And then after whatever they had to do it for, that line, right, the normal forgetting curve is very immediate with a huge drop, but the spaced forgetting curve is much higher. Now, of course, reactivation. So if you keep testing yourself, that actually is the best way to keep that information. So when you are studying, you should also think about the level of your processing. If you are just shallow processing, this is encoding the information on basic level. Like, what's this word? What does it look like? How do I spell it? Deep processing is really thoughtfully encoding, thinking about the meaning of the word, and that yields the best retention, deep processing. Hermann Ebbinghaus, who we will mention many times in this module, in this unit, is a German philosopher who estimated that compared with nonsense material, learning meaningful material required 1/10 the effort. So if it's meaningful, it just makes so much more sense and you're so much more likely to remember it. Self-reference effect is the tendency to recall information relevant to us personally. And this is stronger in Western cultures because they are more individualist. So takeaway, short-term memory is also known as working memory. And remember why that's a more appropriate name. Iconic, think I. Echoic, think echo. Long-term memory is unlimited. The magic number is 7 plus or minus 2. E is for effort, explicit, effortful processing. Spread out your learning, test yourself, and make meaningful connections with the material. And then you will remember it. All right, that sums up our Module 31.